All right, welcome to the very last lecture of the semester. You made it! Woohoo! All right, this is 11.6. We're going to use all of our knowledge of logarithms and exponentials in order to solve. 10 easy problems, well, not easy, but 10 fairly simple problems that if you've got your logarithm rules and exponential rules under your belt, you should be good to go. So, all right. Let's see, we need to use a scientific calculator to solve the following equation for x to 3 decimals. Well, let's see, what do we have here? We know that 3 to the first power is 3, 3 to the second power is 9, and 3 to the third power is 27. So my answer is going to be somewhere between 2 and 3, right? To hit a 12. Now before, what we were doing is we were making the bases the same as far as powers go, but I can't do that here. I can't write a 3 and a 12 in terms of the same base. There isn't anything. All right, so then what? All right, if I had, remember when I had like 4 to the x was 8, there's a base of a 2 in each of these. That was 2 squared raised to the x power was 2 cubed, remember? Now I've got my 2's the same. I can't write a 3 and a 12 in terms of powers of the same base. So I have to use a different method. Okay, so this is obviously your quicker method if it works, but what if it doesn't? Okay, and that's this whole section. This whole section, it's never going to work that way. Okay, so instead what we're going to do is we're going to rely on some of our logarithmic rules. Now, is that a log? No, it's an exponent. It's an exponent, so, you know, then what? Again, then what? All right, but remember we had, now I've just changed the letters on you. Okay, then I won't change the letters on you. A to the x, I know that's what I used last time. It doesn't matter what letters you use where, but I'm going to try to keep things consistent. So if we have a logarithm base b of a to the x, my power rule said that I could drop that down, log base b of a, right? This is a very powerful thing because when my variable is up in the exponential spot, I can't do anything with it to find out what that is because it's in the wrong spot. But if it's down here, I can certainly mess with it, okay? But this is a property that only belongs to logs, not exponents, okay? This does not belong to an exponential. So in order for me to use this property, I have to be working with logs. So in order to work with logs when I don't have one would be to do the same thing to both sides. Remember, I can do anything I want to either side, including logging both sides. Okay, then that's how I turn it into a log. Now I'm going to choose to do either a common log or a natural log because I'm going to need my calculator. I'm not going to choose a log base 2 or pi or any other stupid thing because I can't use my calculator then. So I'm going to choose to take the common log of both sides. I'm going to just switch this up, and sometimes I'll do the common log and sometimes I'll do the natural log, and it does not matter which you do. Okay, just keep it consistent. If you're going to common log this side, you can't natural log this side. Okay, so these both have to either be common or both have to be natural. All right, so this is a valid thing. I've just taken the log of both sides. As long as I do the same thing to both sides, I'm good to go, right? Now I can use my power rule because I've got a logarithm. This x can come down in front, right? Up in here, I can't solve it for it, but down here I can. I've got x times something. X times something to solve would just be divide. Log of 3. So here x is equal to the log of 12 over the log of 3. Now I've purposely chosen a base 10 so that I can use my calculator. So I have the log base 12, close the parentheses, divided by the log of 3, close the parentheses. Now up here, before I show you the answer, we said it had to be between a 2 and a 3, so this answer better be between 2 and 3, right? And it is. Okay, 2.26, how many decimals? 3. 2.262. Okay, so let's just, before I enter that in, I'm going to check my answer. I'm going to see if 3 raised to the 2.262 power is equal to 12. Now it's not going to be exactly 12 because this is not an exact answer. This is a rounded answer, so I'm going to get real close to 12. So when you're checking these, if you're getting extremely close to the number that you're looking for, you're good to go. Okay, so I'm going to just check it this way because pretend I'm in a test situation here. 2.262. And indeed, it's pretty close to 12. Okay, so that's got to be the right answer. Or at least I'm 99% sure that it's the right answer. Obviously, I can't be absolutely sure. But it's looking good. Now, if you come out with a -3, there's no way that's correct. Okay, we're trying to get as close to 12 as possible. All right, same thing here. I can't, oops, I can't, aren't you gonna be glad to get rid of me? All my stupid mistakes that I make all the time. Sad face. All right, again, I'm stuck exponentially, right? I don't know how to solve this, so I'm gonna turn it into a log. So I'm gonna log both sides. This time I'm gonna randomly choose to take the natural log of both sides, because I also have that key. Minus x plus 4 is equal to ln 86. Okay, if I take the natural log of both sides, I'm good to go. Now I'm going to use my power rule that tells me on logarithms that this thing can drop down in front. So I've got -x plus 4 times the natural log of 3 is equal to the natural log of 86. Now I can solve. So I'll start by dividing 3 by the natural log of 3. Okay. So now I have -x plus 4 is equal to the natural log of 86 over the natural log of 3. I'm going to subtract 4 from both sides. So I have -x is equal to the natural log of 86 over the natural log of 3 minus 4. And at the end, I'm just going to take the opposite sign of whatever this is. Okay? So I'm going to divide through by that -1. So I'm just going to change my sign. I don't want to throw it inside of a natural log or anything like that. This means just take the opposite sign. So let's go ahead and see what that is. This time I'm going to use my ln key. I've got the natural log of 86, close my parentheses, dividing by the natural log of 3. I'm going to get an answer. That's this piece right here. I'm going to subtract 4 from that. And I get a 0.05005, right? And then I want that negated. So I want this as a -0.055, right? I've got 3 decimals, that's the thousandths, so I'm going to round that one up. -0.055. All right, so let's check that one. I should have checked it before. I'm going to throw a -0.055 in right there. Okay? So I'm going to take 3 to the -0.055 plus 4 power, and that should be very close to 86. This is negative. Forgot. Negative, x is negative, so the opposite sign of a negative is like a positive, correct? So I take the opposite sign of 6, which would be 3 raised to the 0.055 plus 4 power. And I've got, well, I mean, yeah, it's still close to 86, 0.05. You know, I'm very close to 86. It's because this is not, you know, if I would put in 0.054521.6, I'd get a whole lot closer to 86. Okay, but this is pretty close. It's not as close as the last one, but it's looking good. Okay, so we take the opposite sign of whatever x is, which is a positive, and add 4. That's what I'm raising my 3 to. and trying to see if it works. Okay, I'm not going to do all of these. I think you're good to go on that one. I'm going to just try to maybe do the, like this one I think I should do. Okay. So we have 3 to the x plus 2 power is equal to 4 to the x power. All right, I want these x's dropped. So therefore, I will log both sides. I'm just going to do the common log this time. I'm just going to alternate. Common log of 4 to the x. Okay. My power rule says that both of these can be dropped in front, and this one, because I'm working with logarithms now. So I've got x plus 2 in parentheses times the log of 3. Now the log of 3 is just a number, is equal to x times the log of 4. This is again just a number. Okay? So think of these as just a 2, like a 3 and a 4. Okay, so just think of this as, you know, a 3 and a 4. What would you do to solve for x here? Wouldn't you distribute and then gather your x terms? I'm doing the same thing over here, okay? I'm going to distribute. So I've got x times the log of 3 plus 2 log of 3 equals x log of 4. Okay, I'm going to gather my x terms. Okay, I'm going to want to bring that one over here. So I'm going to subtract x times the log of 3, both sides. Let me get down just a bit. So this is gone. So now I have 2 log of 3 equals x log of 4 minus x log of 3. Okay. Now I'm solving for x. I have 2 x's in here like that. So I'm going to take out my common x. That's called factoring. Yeah. Yuck. And that's what I have left over, right? So now I have x times something. All right. So now I would divide by the something. Log 4 minus log 3. You knew you had to do factoring for a reason. You are not going to cancel those. Okay. So now we have x is equal to, good grief, 2 log 3 over log 4 minus log 3. Woo! All right, well, let's see what we got here. We've got 2 log of 3 divided by, with a parenthesis because I've got division down there, or subtraction down underneath my division. Log of 4, close your parentheses, minus log of 3, close for the log and close for the this one, the containing the denominator. Okay, which would equal 7.638. All right. Well, let's check it. 3 to the 7.638 plus 2 power should be the same as 4 to the 7.638 power, or at least fairly close to each other, right? So 3 raised to the 7.638 plus 2 power is this icky-decimal, and 4 raised to the 7.638 power is sort of the same icky-decimal. Boy, that's off by 4, right? But that's because we've rounded this. So if I got something that was like way, way off, I would know that that's not quite right. You can also start dragging out your decimals more and see how much closer we get. Let's just try that once. Let's try, instead of this number, let's try 7.637683. I'm going to go all the way out to this decimal and just see what happens. 3 raised to the, okay, so I'm supposed to add 2 to that, so it's 9.63, blah, blah, blah. 9.637683. And then I'm going to raise 4 to that same number, which is 7.637683. Let's see how much closer we get. Look at how much closer that is. Now we've got the same number here, and then it starts to deviate in the third decimal place, doesn't it? But this would be rounding to 3. So, I mean, this is the correct answer. It's just that we've shortened it, and so it just throws it off, especially when we've got large numbers like this, like really big or really small. It'll throw it off even more. Okay, so sometimes if you want to, triple check on a test, just drag these out a bit more and try it if it's not quite looking like it's the right one. Okay, so let's try this. Yeah, that's fine. Okay, that was a harder one just because of the algebra of solving for x. I mean, that took a lot more. Okay, so remember that log 3 is just a number. It's this icky decimal, but it's just a number. So it's like a 2x or a 3x. And log 4 is a number too. So, and 2 log 3 is just a solid number as well. So don't let those bug you. Okay, so far what we've seen on all of these is we have an exponential that we can't solve. Exponential, 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 and exponential. So what did we do? Well, we turned it into a logarithm, didn't we? Yep, we were stuck on the exponential side, so we logged both sides. Now on these, we're going to be stuck logarithmically. So what do? Well, we're going to turn it into an exponential. Whichever way you're stuck, you've got to go the other way. Like on this one, I have no idea what I could put in for x to make that into a 3. I don't even have a log base 5 button. Okay? So let's just do this. Let's get a new screen for a new section, for a new type of problem. It's not a new section, but it's a new type. And let's write this down. We've got log base 5 of 2x minus 8 equals 3. Let's get our log base b. Oh, what letter did I use there? Shoot. C equals a? I can't remember. And then b to the a is c. I don't remember what letters I put in here before. But it doesn't really matter. Like I said, b to the a is c. If this was c and this was a, then just it's backwards. It doesn't matter. These are just generic. Okay, so I've got this, don't I? Isn't b 5, c is the 2x minus 8, and the a is the 3. So I want to turn it into this. So I've got 5 cubed is this. 5 cubed is 2x minus 8. Well, that's easy to solve. That's just a linear problem. I've got 125 on this side. Simple, easy peasy, isn't it? Yeah. Add 8 across. So I've got, what do I have? I have 133 is 2x. And come on, divide by 2. So x is 133 halves. Yuck. How do you check that? I will come back and I will show you after I get to problem number 8, I believe. Okay? So don't forget that. I will come back, I promise. All right, here's another one. Same thing, right? I'm stuck as a logarithm. I don't have a log base 3 button. I can't put an x in there. Even if it was a log 10, I can't put an x in there. Okay? change it over to an exponential form. 3 squared is this. I'm not going to do this one for you because it's too easy. Solve for x. Okay? The checking piece of it will come later. All right, don't look over here. I hate when they're on the side. What do we have here? We have log base 10 of x plus 3 to the 5th power is equal to 3. All right, I have a log base 10, which is great because I have my log base 10 button, which is right here, but I can't put an x in there. It won't solve it for me, so that doesn't do me any good. So again, even though it's a 10, I'm still stuck as a log. So I'm going to change it to 10 cubed is this. So I've got 10 cubed is x plus 3 to the 5th power. Okay? And I'm solving for x. Okay, I got to get rid of that 5th power first, don't I? How do I get rid of a 5th power? What do I want it to turn into? I want it to turn into a 1st power, so it's not there. How do I get a 5 into a 1? Well, I would probably raise it, this whole thing, to the 1/5 power, right? Because 5 times a 5th is 1. Well, I'm going to have to do that to this side as well. Okay? So this side over here, just these wipe each other out, and we've just got x plus 3. And this is, let me just go up here, we have 10 cubed raised to the 1/5 power, and remember powers of powers is multiplication, so we have 3 times a 5th, which is equal to 10 to the 3/5 power, right? 10 to the 3/5 power. Subtract my 3 across, and I've got minus 3 plus 10 to the 3/5 power is equal to x. Now my answers all up in here are in radical form, so I'm going to have to use that radical conversion. Okay, again, yes. How many times are we going to use this? I'm here, I want to go there. Okay, so I've got negative 3, I've got to get that negative 3 in the, on the beginning because that's the way these are. Okay, plus, and then I've got my 10 underneath here, and I'm going to have my numerator, which is my 3 here, and my denominator here as my index. And 10 cubed can be, and if you have to, you can use your calculator. It's 1,000. So it's negative 3 plus the 5th root of 1,000. Negative 3 plus the 5th root of 1,000 is option number B, right? Do you like multiple choice? I kind of do and I kind of don't. Multiple choice is always, they give you the most common mistakes. That's what I don't like about it. They don't always give you one answer and the other 3 are just ridiculous. They give you other ones that you go, okay, these are the most common mistakes that people make, and we see these mistakes all the time. So you have to be very, very careful, okay? All right, so that's it for solving as a log to an exponent or an exponent to a log, all right? This last little piece is going to go super fast. It's only 3 points in through here, and this is the way that we can check those logs, okay? So we're supposed to evaluate this. Log base 8 of 14. Well, I can't, right? I can't. I don't have a base 14 button. Okay, so my change of base formula says change of base formula says that if I have a log base b of x, that's the same as the log of base 10 or ln, okay, because I have to choose one of those two because that's the only thing that my calculator can do. The log of x over the log of b, or ln x over ln b. Okay? So here's my b, here's my x, so this is either equal to the common log of 14 over the common log of 8, or it's equal to the natural log of 14 over the natural log of 8. Either one. So we have the log of 14, close your parentheses, divided by the log of 8. Or we have the natural log of 14 divided by the natural log of 8. Should be exactly the same, and it is. 4 decimals, 1.2691. Good job. All right, so this is a way of checking it. So let's just go back. Where were we? Maybe not that one. Which one did I say? I think it was this one. Yeah, it was. Okay, so let's use a change of base to check that one. Now we can. Oh, I'll do 2 more change of bases first. I'll come back to this. This is number 5. Let's just try one more. I'm using this. Okay. So I've got the log of base squared of 2 of pi. Oh, could that look more nasty? I don't have a log base square root of 2, so I'm going to say it's the same as the common log of pi over the common log of the square root of 2, which could also be used the natural log of pi over the natural log of square root of 2. So I'm going to use a natural log just because I can. The natural log of a pi divided by the natural log of the square root of 2. And that one's closing the radical sign, then I need another closing for the ln sign. So we've got 3.30, 4 decimals, 3. Excellent. All right, and number 10 is the same. I'm not going to do it. It's the same stuff there. So let's go back to number 5 and see if we can't check this. All right, so now that we know the change of base, we have the log base 5 of 2 to the 133 seconds minus 8 equals 3. This is not as nasty as it looks, though. So let's first of all clean that up. 2 times 133 halves is 133. And 133 minus 8 should be 125. God, I'm starting to go brain dead here. 125. So we have this. That's what we're saying, because 2 times this is 133 minus 8 is this. So this is basically what we're saying is true. Well, so based on the change of base formula, we're going to change these over to base 10, and that should be equal to 3. Okay, I'm going to take that divided by that. And if it's not, then we've done something incorrect in here. So log of 125 divided by the log of 5 should be exactly 3, and it is. Okay? So once you put your answer in here and simplify it as much as you possibly can, then use your change of base on this side and see if it equals that side. Okay? Sometimes it's a lot easier than others to check these, but at least you've got some way during a test that you can check those. Okay? But that's it. I'm going to be sad to leave you guys. Hopefully I'll see some of you in my college algebra class face to face. That'd be wonderful. I do college algebra very similar to this in a face-to-face class. Where I try to do as much of the homework as possible and try to give you the most important critical information that I can. It's a big step, though, from this class to the college algebra. It's a big jump. It's not an easy course, and we go into great depth in all of the stuff that we covered in this class. So I would suggest, keeping your notes. That's key. Keeping your formula sheets. Whoever teaches you this particular, the next level, all that stuff will come in handy for you. So, well, it's been a pleasure, and I'm proud of you that you got this far. Wherever you're heading, best of luck, and I will see you another time. Take care.